Here we have an OsaiRing. We're going to apply 24 volts DC to the M5 connector, the two outside pins of the three. And we'll see how the LEDs turn on. Oh yeah, this is bad. You see that flashing green LED? That should be steady on. And then after a moment, the red LED will turn on here in the shop. That's how they turn on. Let's go inside and let's see if we can fix that power supply. Just a screw. There we go. There's the relay output board right there. These are all the relays right here. At the moment, we're not concerned with that board. We want to take this board out. There we go. We're in. Get this ribbon cable off. Oh, no, I better leave it on. I'm going to snap the strain relief. I heard it crack. Okay, now this is the DC to DC converter right here. That takes our 24 volts DC in and converts it to 5 volts for the logic right here. These hybrid modules, these are the input hybrid modules. They're opto-coupled input. And here's the Xilinx. Its part number is XC3042A-7. And I've seen different types of field programmable gate arrays in here. I've seen a couple from Lucent Technology, and their part number was 3042. But usually it's a Xilinx part. Here's the configuration IC. When you first power this up, data from the configuration IC is sent to the Xilinx to program the I/O of the Xilinx. This capacitor right here is on the output side, the 5 volt side of the DC to DC converter. Now there's a bridge rectifier right here between the X5 connector and the DC to DC converter. The DC to DC converter part number is GS-R405/2. And you'll see different DC to DC converters in here. I've seen smaller ones in a smaller 1 amp package. So you can apply, with this bridge rectifier, you can apply AC in or DC in. Now, the very first thing, you see this capacitor right here. Before I start messing around with the DC to DC converter, I'll change this capacitor right here. It's not a very big valued capacitor. I think it's 22 microfarad. Let me get my close-up glasses on so I can see that part. I'll have to look at it when I get that off because I don't see the part number. There it is, yeah, it's 22 microfarad. So what I'm going to do, I'm going to remove this capacitor and I'm going to upsize this value right here to give it more filtering. This is across the 5 volts. And 9 times out of 10, the problem with the power supply, the reason that it doesn't come up steady and that green LED flashes is because this capacitor right here has gone bad. So let me fire up the soldering iron and we'll change that capacitor. Before we change that capacitor, let's take a look across that from VCC to ground. Okay, I'm applying 24 volts DC to the M5 connector, and we should see a good clean 5 volts. I think that's bad. That'd be a perfect clock signal right there. This should be a steady 5 volts, but you can see where it rises up and falls, rises up and falls. Okay, we got to change that capacitor and then see what it looks like. Okay, so let's remove the capacitor. This is it right here that we're going to remove. Add a little bit of solder to help the old solder flow. I'm going to take my hook pick and hook it around one side of this. Heat up the one side and then with the hook pick pull it out. Okay, that's one side. One side is undone. Now we can heat up the other side and take the capacitor out. There it is right there. See if I can get a good read on that value and voltage. Okay, it's 22 microfarad at 25 volts. We'll put that on the sync core here in a little bit and see if it's bad. Now to get the solder out of the vias. Turn the board right here so I can hold it steady. Should be good enough. Yep. Okay. Now I'm going to take in parallel two 100 microfarad 25 volt caps, and that way you can have a 200 microfarad filter capacitor right there. When you parallel the capacitors, you want to make sure that you have the positive side to the positive side and the ground side, the negative side to the negative side. And then just easily bend one side over and then twist it around the other. Bend that side over, twist it around, and we'll take some solder and solder those two together. And then trim the leads back. There's one side. There's the other side. We've created a capacitor from two single capacitors. Let's install that into our board. Looks good right there. Now let's see what we look like. See if we get a steady green LED and a good waveform on the oscilloscope. Applying 24 volts DC to the M5 connector. Look at that. We have steady green LED, and a moment later the red LED turns on. And now we have good 5 volts on the oscilloscope. Let's go look at that oscilloscope. There you go. That is perfect. We have a good steady 5 volts now. You fixed it. Good job, folks. You fixed it. Connecting the ribbon cable to the relay output board. Oh, looks good. try it again. There we go. Let me turn this overhead light off. There you are. We have steady on LEDs now. Good job, folks. You fixed another one. Good job. She can go back in the machine and go back to work. Let's try that capacitor on the Sencor. Let's go test it. Let's see what it looks like. How it failed. We'll look at the value, the ESR, equivalent series resistance, and the leakage of this 22 microfarad 25 volt capacitor. All right, let's turn on our Sencor. We'll do the lead 0 open. That's done. Now we'll join the clip leads together and do the lead 0 short. And that's done. Now we'll put in our parameters. It's aluminum lytic, 22 microfarad, 25 volts, and let's give it a tolerance of plus and minus 10. We'll clip the red lead to the positive side. And the black lead to the negative side. Let's push our capacitor value. It says 16.54 microfarad bad. It's a little bit low. Let's do our ESR test. 9.0 ohms, good. Let's do our leakage test. And the leakage is 2.89 microamps. That's good. So the only problem with this capacitor was its value was low. There we go. Changing out that capacitor. Fix that OsaiRing.